So this is example number 3 from section 10.4, which is about finding determinants of square matrices. And here I have a 4x4 square matrix. Okay, so you can guess that 2x2 was pretty easy. A 3x3, we had to break it down into 2x2, so it's a little more involved, right? Now we're breaking this down into, this is a 4x4, so I've got to break it down into 3x3s, and then break those down into 2x2s, okay, and so forth. So that turns out that that's going to be a lot more work, so you definitely want to be a little more strategic about how you choose your row or your column. And this column right here has 2 zeros in it. So I definitely would use that. Okay, so I'm going to have 5 times its minor. So you're going to eliminate the row in the column. It's going to be this 3x3. If I'm doing with 5, this is the 3x3 that goes with it, and so forth. Okay? So as I go through and I expand this using the first column, and this is going to be quite a bit for you to look at here, but see, there's the 5, and then these 9 elements, those are the 9 elements that are here, okay? And so then, when I'm looking at the 4, because that's the second one, I'm going down this column, so the second one is a 4, but notice it's a minus because you've got, technically it's a plus 5, it's a minus 4, it's a plus 0, and then technically this would be a minus 0 here, all right? If you're following the alternating signs, because as I was showing you before, if you got plus, minus, if you're going down this way, it looks like this for this checkerboard pattern. Don't know what I was doing right here. So with a 4x4, when you choose any row or column, you've got this checkerboard pattern. Since I am picking this first column, the first number, it's plus that, then it's minus the second number, so minus the 4 times its minor, and then plus the 0 times its minor, and then minus the 0 times its minor. So when I'm trying to do the second one, the 4 here, that is this. Here's the 4. So I eliminate its row and its column, and you'll see that what I have left is 306, 2 negative 3, 4, and 1 negative 2, 2. These other two, really, I don't even need to write them down. Okay, I wrote them down because I wanted to show you that that is what you would get for this zero's minor. This would be that these 9 values. For this zero's minor, it would be these 9 values. But I don't really need to do that because 0 times anything is just 0. Okay, so no need to do that. All right, so hopefully you're with me so far. Now, what happens now is that I have to go through and I have to find the determinant of this 3x3. And you can do it using expansion by minors like the one I just did, okay? And then you're going to do this one and do expansion by minors like the one I just did, okay? Now, there's not a whole lot of room here, so I'm going to go through and I'm going to find these, but I'm going to do it on a separate sheet so I can show you. But this would be probably a good opportunity for me to show you the alternate method, okay? I think you're gonna, when it comes down to a 3x3, I prefer to use this other method. So I just need to copy these down. So I've got 6, 4, 12. Two, negative 3, 4.
1 negative 2.
And 1 negative 2, 2. So I could do expansion by minors, but this method is called the diagonal method. Okay? So bear with me for a moment, and that's why it's good that I have this on video so that later on you'll be like, wait, how did he do that before? And then you come back and rewatch this video. The first thing I do is I take this column 6, 2, 1, and I'm going to recopy it and make like a new column outside the determinant. I'm doing it in a different color so you know that it's not part of the original determinant. So 6, 2, 1. I'm going to do the same thing with the second column. 4, negative 3, negative 2. And you would think I would do the third column, but I'm not going to. Okay? You'd be like, well, you did it for the first two, but you'll see as I do this, this is called the diagonal method. I need those to help me do my diagonals, all right? So bear with me for a moment. So here's what's going to happen. I'm going to get 6 products. All right, 6 products. The first 3, the first one, the second one, and the third one, they are all going to be added together to get part of my total. All right. The next 3, I'll do this in a different color so you can see this. The next 3, I'm going to subtract those numbers, whether they're positive or negative. I'm going to subtract. If it's a negative number, I'll subtract the negative number, and it'll be just like adding. So you can see there's 6 blanks there. First 3 you add, the next 3 you subtract. It's probably the worst part of all this. Then here's what you do. This is where the diagonals come into play. You're going to start here at this 6, and you're going to look at the numbers. If you went diagonally through that 6, what 3 numbers it would go through. And you could use a pencil or a ruler or something. You can see diagonally the 3 numbers that I go through are 6, -3, and 2. That's what you're going to multiply together. 6 times -3 is -18. -18 times 2 is -36. That goes in my first blank. I'm going to do the same thing with the 4 and with the 12. That's where my first 3 products are going to come from. So I'm going to do a diagonal going through the 4. That's why I needed these numbers on the outside. I've got 4 times 4 times 1 is 16. Then I go through, and if I line these up better, it would look better, but the 12 times 2 times -2, so that's -48. The other 3 come from going this way. So now I'm going to go up from the bottom row here, diagonally. So I'm going to be going up through here. 1, -3, and 12 comes out to be a -36. So this is what I was saying before. It's a minus. That's why I go and write it down. It's minus a -36. So technically, I'm going to end up adding 36 there. And then I go through this diagonal. So I've got 6 times 4 and 24 times 2 is 48. So a -48. So I'm going to be subtracting a -48. And then the last diagonal, 2 times 2 times 4 is 16. Now, as it turns out, I can see from here I got a -36 to +36. I've got a -48 and a +48. I've got a +16 and a -16. This all actually turns out to be 0. Okay? So back here on this previous one, I just figured out that 5, its minor, this is what we just did, its minor is 0. So now I need to do -4. I've got to figure out what is this determinant. So I'm going to pause the video for the people in class to go through this. You're at home, pause the video so that you can try to do that one on your own. So I don't care which way you do it. Do expansion by minors or do determinants. I'm going to give you a minute to try to do that part, and then I will start the video up again. Okay, so hopefully you've had enough time to try to do this problem. Again, I have set up the 3x3 here, and I've recopied the first column on the outside, recopied the second column on the outside. And so then you could do it this way, like it'll get a little bit messy, I think, but you could circle these if you want to, going diagonally through here. It's almost like a seek and find. 3 times -3 is -9, times 2 is -18. So that's my first number that goes here. And then this one, 0 times 4 times 1. Well, 0's involved, so it doesn't matter. It's just going to be 0. And then I've got 6 times 2 times -2. So 6 times 2 is 12. 12 times 2 is 24. It's a -24. So now I start doing the other diagonal. This is why I said it gets a little messy here, but 6 times -3 times 1 is a -18, I believe. So it's going to be minus a -18, which I can already see is going to cancel out with this one. And then go to the next diagonal, this one right here. 3 times 4 times -2, that's a -24. So you're subtracting a -24. Again, that cancels out. I can do the math as I'm going if I need to here. And then 2 times 2 times 0 is just 0. So this one also turned out to be 0. They don't always turn out to be 0, folks. All right? But in this case, both of these determinants turn out to be 0. Sometimes they do. So, as I did each of these, Those two things got to cancel out. This determinant was 0, this determinant was 0, so then you're taking 5 times 0 and 4 times 0, and then you got plus 0 minus 0. That all turns out to be 0 for that determinant. And again, it can turn out to be like 25, -7. It's going to be some sort of integer value when you get to the end.